Good morning. Today you will work on section 10.2.1 notes, and with 10.2.1, we'll start our journey of probability. With any question with probability, most of the questions that you will face would be a two-way table. And with this question, you have a university for people that majors either in engineering or they major in other different majors other than engineering. But also people also sometimes live on campus and live off of campus. With any two-way table, the first thing that you will do even before you start your questions, that you will have to add the row totals, the column totals, and the grand totals. With the grand total, I like to put it in a big box. And with the grand total, I'm trying to add everything, all of these numbers. So 30 plus 170 plus 6 plus 34, that's all equal to 240. Now, also with that being said, the 30 plus 6 is 36. 170 plus 34 is 204. Now I'm going to go on to the row totals. So 30 plus 170 is 200. And 6 plus 34 is 40. Moving on, the first question, what's the probability of a student living on campus? So all of the people that live on campus, we just figured that out. There were 40, which is the 6 and the 34. So they add up to 40. So it would be 40 out of the grand total, which is 240. And when you change this one to a decimal, it's 0.1667. So kind of 16.67% of the students in this university live on campus. The second question, now we're going to be introduced to a conditional probability. The question is said, what is the conditional probability of a student living on campus, given that you know the student is an engineering major? So you want to figure out with this question, you want to figure out what's the probability that a student live on campus. But the condition, you're looking at the condition given that that student is an engineering major. So out of the people that are engineering major, how many of them live on campus? So this is how you phrase this one. So at this point, when you get to a conditional probability, you're not dividing by the grand total, you're dividing either by a row total or a column total. So out of how many people there are engineering majors, this is 36. Out of them, how many of them live on campus are the 6. So there are 6 out of the 36. There are like engineering, out of the people are engineering major, you have 6 of them live on campus. So 6 out of the 36 is equal to, when you simplify this one, it's 0.1666. So this is the first time that you're introduced to conditional probability when you're dividing either by a row total or a column total, depending on your question, but you're never dividing by the grand total. The following part of this lesson also, they're checking if two events are independent. With the two events are independent, if you have any two events and you want to figure out whether they're independent or not independent, you're trying to figure out if the probability of A, if this A is my first event, is that equal to the probability of A given B? If they're both equal to each other, then we can say they're independent events. If they're not equal, then they are dependent or associated events. And this is the table that you had in the beginning of the notes that you have in front of you. So again, if two events are independent, then the probability of A is equal to the probability of A given B. With that being said, you have to check the calculations of the first part and the calculations of the second part, and then check if the two probabilities were equal to each other or not. Now, they're asking you for this question, the two events, which is living on campus and engineering major, are the two events independent? So I will look, the first one, if I want to prove that, I want to figure out what's the probability of live on campus. And I want to check, is that equal to, and so I'm putting now a question mark because I didn't check that yet. Is that equal to the probability of live on campus given that you're engineering major? So living on campus, the probability of living on campus, we found that in part A, which was 0.1667. So it was 40 out of the 240, which was equal to, simplifying this one, it was equal to 0.1667. The second part, the probability of living on campus, given that you're an engineering major, this was given to you in part B, which is we calculated this one. It was 6 out of 36, which was simplified to 0.1667. Now, both of those probabilities were equal to each other. So they're equal at this point. I can confirm they're equal to each other. So the two events are independent. The last part of this question, they're talking about mutually exclusive. So a mutually exclusive event, you can check that by seeing the probability of A and B. The probability of A and B, is that equal to 0 or not? If they were equal to each other, then you can say safely they're mutually exclusive. Which means, in a different word, what does it mean by mutually exclusive? Means the two events cannot happen in the same time. So think about it. The two events cannot happen in the same time, then will be mutually exclusive. So the question here they're asking you is, are the events on campus and engineering mutually exclusive? So if I look back again in the table and I want to figure out what's the probability of on campus and engineering major, with the probability of on-campus and engineering major, if I looked at in my table, it's 6 out of the grand total. This is not a conditional probability. You're dividing by the grand total, so 6 out of the 240. It's not equal to 0. So since they're not equal, it's not equal, this probability was not equal to 0, then you can say the two events. So the two events are not mutually exclusive. Here is a different table. The first thing when you have a two-way table is try to add the row totals, the column totals, and again, the grand total. Again, this 200 is coming from 30 plus 170. The 40 in the second row is coming from 0 plus 40. From the first column, you have 30 plus 0 is 30, and then 170 plus 40 is equal to 210. The first question is asking you, are the events living on campus and engineering majors associated? So whether they're asking you whether it's independent or associated, you're checking the big rule that says the probability of A, is that equal to the probability of A given B? If the two of them are equal, then they're independent. And if they're not equal, then they're either dependent, or we can say that they're associated as well. Let's check this one. So I'm going to figure out what's the probability of living on campus. And the probability of living on campus, you have 40 students out of the 240 live on campus. So 40 out of the 240. And you will check if that is equal to the probability of living on campus, given that you have an engineering major. So this is a conditional probability. Out of the people who are engineering major, how many of them live on campus? Out of again, the people that are living, they're engineering major. So the people who are engineering major are 30 students. Out of them, how many of them live on campus? There's 0 that lives on campus. So this probability is 0 out of 30. If I simplified my left side and my right side and to check if they're equal to not equal to each other, the 40 out of the 240 is equal to 0.1667 simplified. 0 divided by 30 is 0 still. So eventually they're not equal to each other. And when they're not equal to each other, then the two events, so since they're not equal, they're dependent or associated. So the two events are associated. Now for B, Are the events living on campus and engineering major mutually exclusive, which means do they happen together? To check this one, you can check the rule, the probability of A and B, is that equal to 0? If they were equal to 0, then they're mutually exclusive. So I'm going to check the probability of on campus and engineering major. So how many students live on campus and in the same time are engineering major? And eventually, we did this one previously. It's the intersection between the two events. So living on campus and engineering major would be this 0 out of the 240 grand total. So 0 out of the 240, which results into 0. So eventually, the two events are mutually exclusive because simply the probability of A and B is equal to 0, or the intersection between the two events is equal to 0. This is the last question from the notes from section 10.2.1. I would recommend that you try this question on your own first. So pause me, try this question, and then after you're done, come and check the remaining of this video. First of all, I'll start by completing my table. 7 plus 5 is 12. 7 plus 13 is 20. 7 plus 7 is 14. 5 plus 13 is 18. And my grand total, usually I put it in a box, it's 32. And the first question is asking, what's the probability of being a female in the class? So there are 18 females in this whole class. So it's divided by, so the probability of a female is equal to 18 out of the 32, which simplifies to 0.5625. Second question, what's the probability of being a female given that you're wearing jeans? So out of the people that wear jeans, so this is your condition, how many of them are females? So the question again is saying that what's the probability of a female given that you wear jeans? So the people that wear jeans, there are 12 people out of this class that wear jeans. Out of them, how many of them are female? It's the 5. So it's 5 out of the 12, and that's equal to 0.4167. The following question is asking, are the events female and wearing jeans associated? Or if they can ask you about independent or dependent, all of them you have to check the big rule that says the probability of A, is that equal to the probability of A given B? If they were equal, then the two events are independent. If they're not equal, then the two events are dependent. I'll pick for my female A, and I'll pick for my B, for my second event B would be wearing jeans. So I want to figure out, is the probability of female, is that equal to, so I'll put a question mark, is that equal to the probability of female given that you wear jeans? The first one was found in part A, which was 18 out of the 32, which simplified to 0.5625. The probability of a female given that you're wearing jeans was 5 out of 12, which simplified to 0.4167. As you see, those two probabilities are not equal to each other, so you can simply say that the two events are associated. So the events are associated. Last question. Are the events female and wearing jeans mutually exclusive? So you want to figure out, can the two events happen in the same time? So I want to figure out what's the probability of A and B. So the intersection between the two events. If the intersection between the two events was equal to 0, then the two events are mutually exclusive. So I want to check out what's the probability of a female and wearing jeans. So the probability of a female and wearing jeans, looking at the table, it would be the intersection between the two events, the female and wearing jeans. So there were 5 out of the grand total, which is 32. Eventually, this is definitely not equal to 0. So the two events are not mutually exclusive. Thank you and have a great day.